Hi, today we're going to look at one of the most basic, probably the most basic application of derivative, and that is the tangent and normal line to a curve at some specific point. So, the most basic application to the derivative is for f prime of x at x equal a is the slope of the tangent line to y equals f of x at x equal a. And so if we have some basic curve and some value a, and I look at this tangent line to the curve, the slope of this line is going to be the derivative at a, which means this point being the point a comma f of a, this means the equation of the tangent line would be y minus f of a is equal to f prime at a times the quantity x minus a. It's the point slope form of a line. And we can just leave it in that form. We don't have to write it in slope-intercept form. So let's look at some examples. I will get to the normal line to a curve in a minute. So let's suppose that I have y is equal to the cube root of x over x plus 2, and I want the equation of the tangent line at x equal 8. Okay, so first off, I'm going to write this as x to the 1/3 over x plus 2, and then I will now take the derivative, y prime. Notice this is a different function, so I have to label it. When I'm doing simplification for my original function, I can just write equals, etc., and do simplification. Now this is a different function, so don't just write equals. Totally different function. And I'll use my quotient rule. This would be bottom times the derivative of the top, 1/3 x to the negative 2/3 minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. Okay, this is my basic derivative. Now, I really don't care about the derivative rule in this particular example. What I care about is the number. I really care about the derivative at 8. And so rather than simplifying this algebraically, I am just going to put in x equal 8. And so then I'll deal with simplifying the numbers. And so this becomes 10 times 1/3 times, well, 8 to the negative 2/3 would be the cube root of 8, which is 2, to the negative 2 power, which is 1/4. 2 squared is 4, the negative makes it 1/4. Minus the cube root of 8, which is 2, over 10 squared, which is 100. And so if I kind of simplify this a little bit, and I'm going to do a little reducing, make life a little easier. And if I notice here, this gives me 5/6 minus 2 divided by 100, which if I want to, I can multiply by 6 over 6 to the entire big fraction, and I get then 5 minus 12, which is negative 7 over 600. Okay, this is my derivative at 8. And so therefore, based on what I said earlier, the equation of the tangent line is going to be the y value for the point y minus that y value equals this slope times x minus my x value. Well, I don't have that yet. I have the derivative value at 8. What I don't have yet is the functional value at 8. The functional value at 8 would be the cube root of 8 over 10, which is 2 over 10, or 1/5. And so now the equation becomes, again, this is the equation of the tangent line. Yeah. Y minus 1/5 is equal to negative 7 over 600 times the quantity x minus 8. I am using this expression right here. Y minus my functional value is equal to my derivative value times the quantity x minus my x value, in this case 8. Okay? Now, I mentioned the normal line, and so I'm going to keep this up here. The normal line to a curve at a point on the curve is the line perpendicular to the tangent line to the curve. At that point. So basically, the normal line to this curve at point x equal a would be the line that is perpendicular to the tangent line. This is my normal line. This is my tangent line. This would be my normal line. Okay. Now, the nice part is that given what we know about perpendicular lines, the slopes are negative reciprocals of each other. So if I find the equation of the tangent line, it's very easy to find the equation of the normal line to the curve at the same point. The normal line at the same point, again, this was my tangent line. The normal line would be y minus 1/5 is equal to positive 600 over 7 times the quantity x minus 8. Right? The slopes are negative reciprocals. If I look at the slope here and the slope here, they are negative reciprocals of each other. Everything else is the same. Okay? So if you have taken physics at some point in time, you have seen the tangential vector and the normal vector. If not, you will, and you do need to take physics, you will see that coming up. And again, it kind of makes sense what I'm saying here, or it will when you take physics. Let's look at some other examples. So again, your basic tangent line is, to y equals f of x at x equal a was y minus f of a is equal to f prime at a times x minus a. Quantity x minus a. This is your basic form that we're using. So, suppose I have y equals x squared plus x plus 6 over x plus 2. And I want to know where is the slope equal to 1/2. So in this case, I'm not letting x be a half. I want the slope to equal a half. So the first thing I would do is find the derivative. And again, I will use my quotient rule, bottom times the derivative of the top minus the top. Derivative of the bottom is just 1, all over the bottom squared. This is my basic derivative, and so I want to find x such that this derivative, x plus 2 times 2x plus 1 minus the quantity x squared plus x plus 6 over x plus 2 quantity squared is equal to a half. And now this just comes down to a basic algebra problem, solving this equation. So this becomes this is 2x squared plus 5x plus 2 minus x squared plus x plus 6 over x plus 2 quantity squared is equal to 1/2. And so I'll erase all of this. We then get when I subtract, I get x squared plus 4x, and 2 minus 6 is minus 4 over x plus 2 quantity squared is equal to 1/2. And then this becomes 2x squared plus 8x minus 8 is equal to, I'm multiplying both sides by 2 times the quadratic squared. The quadratic squared is this linear factor squared is going to be x squared plus 4x plus 4. And so therefore we end up with x squared plus 4x minus 12 is equal to 0, which in this case it factors nicely, x plus 6 times x minus 2, and so x is equal to -6, or x is equal to 2. So where is the slope equal to 1/2? Well, it occurs when x is -6 and x is equal to 2. If I wanted the entire point, I could substitute back in. Usually when we say where, we're talking about x coordinates only. But if I wanted the point, I could substitute in and get the entire xy point. Okay? Again, recognize the difference between the derivative at a value and the derivative is a value. Suppose I have, let's eliminate this example. And let's suppose I want to show that some particular value cannot occur for a derivative. Suppose I have y is equal to 3x plus 4 square roots of x, and I want to show that there is no tangent line with slope 1. So, how do we show that something doesn't happen when you have an infinite number of possibilities? This is a logic problem at first. How can we indicate that something never occurs when there's an infinite number of things to try? Well, the way we do this, we show it never occurs by assuming it does occur and then the result, that assumption results in some impossibility. By assuming it does occur, with the result being an impossibility. It is kind of like saying, if I went to the store, then I would buy Diet Mountain Dew. I'm a very big Diet Mountain Dew drinker of soda. And so if I said, if I went to the store, then I would buy Diet Mountain Dew. Since I don't have any Diet Mountain Dew, I didn't go to the store. And it's, the idea is that, if I make the assumption here and I don't get get an impossibility here, get something that doesn't work, then that means the original assumption had to be wrong. So let's assume, I'm ready to deal with the problem now. Let's suppose that the derivative at some value c is equal to 1. I don't know what c is. I don't really care. I'm just going to assume that the derivative does equal 1 at some value. And so first I need to find the derivative. The general derivative, y prime, is going to be, in this case, well, let me rewrite the function. Y was equal to 3x plus 4 square root of x, which is the same as 3x plus 4x to the 1/2. And now my derivative then would be, again, notice different function, label 3 plus 4 times 1/2 x to the negative 1/2. I'm using my derivative rules, which then becomes 3 plus 2 over the square root of x. This is my basic derivative. And now I assumed that the derivative at some value c was 1, and so therefore 3 plus 2 over the square root of c would have to equal 1. And now let's see what this would leave us. This would mean that 2 over the square root of c would have to equal negative 2, or the square root of c is equal to negative 1, which you should recognize that this is impossible. The square root is always some positive value, or non-negative value, could be 0. But because this led to some impossibility, we would then say, therefore, no such value exists, which is exactly what I wanted to show. There is no tangent line with slope 1. It led to something impossible. Okay? Let's look at one last problem here. Slightly complicated one, but suppose I have the following. I want to find the area formed by the x-axis the x-axis and the tangent and normal lines to the curve y equals 6x minus 2x squared at x equal 2. Okay? Y equals 6x minus 2x squared is a parabola that kind of opens downward. I don't really care what it looks like. The main thing I care about is that, so this is, again, the statement of what I have. Note here, the functional value at 2 is going to be 12 minus 8, which is 4. And so my functional value at 2 is 4. Okay, so if I wanted to draw a little picture here, there's my x-axis, and I don't really care about the y-axis, but this would be the point 2, 4. And whatever my curve looks like, again, it's going to be a downward parabola. I don't know if it's like this or if it's like this. You know, where exactly this parabola is, I don't really care. But the point is that I'm going to have, let's assume that, you know, it looks kind of like this. Again, I don't know and I don't really care, but let's assume it looks like this. My tangent line is going to look like this, and my normal line is going to look like this. And so we're going to get a triangle that I want to find the area of. So again, this picture may not be exactly correct, but it's good enough to kind of give an idea of what's happening. So I need the tangent and normal lines. So let's go back to what I was talking about. My derivative in this case is 6 minus 4x. And so the derivative then at 2 would be the slope of the tangent line. And so since I have both of these things going on, I'm going to write m sub tan. This would be my derivative at 2, which is negative 2. 6 minus 8. Which means, since the derivative of the tangent line is negative 2, that would mean the derivative of the normal line would be positive 1/2, the negative reciprocal. And then we would get the equation of the tangent line would be y minus 4 is equal to negative 2 times the quantity x minus 2. My picture is not exactly correct. My parabola is, I'm on the wrong side of the parabola, but that's okay. And my equation of the normal line would be y minus 4 is equal to positive 1/2 times the quantity x minus 2. Now, as I say, this picture is actually a little bit incorrect. What we have instead is my parabola actually does something like this. So the tangent line is on this side and the normal line's on that side. Tangent line has a, oops, no, I was right the first time. Anyway, shouldn't have messed with it. Tangent line has a negative slope, which means it does this way. Yeah, I was right the first time. Should have just left it. Normal line is positive slope, so it goes that way. Looks something like this. Anyway, what I need are the x-intercepts, because the area of a triangle is 1/2 base times height. And so I need the x-intercepts to kind of get the length of the base. The height is simple. The height is just going to be 4. So that part's easy. So we need the x-intercepts for both of the tangent line and the normal line. The x-intercept occurs when y is 0. And so we have, for the tangent x-intercept, I get negative 4, because y is 0, is equal to negative 2x plus 4, which gives me negative 2x is equal to negative 8, so x is equal to 4. So this value here is when x equals 4. And for the normal line, the x-intercept would be y is 0, negative 4 is equal to 1/2 x minus 1. Or 1/2 x is equal to negative 3, so x equals negative 6. And so this value is when x equals negative 6. And so therefore, the area, using my basic formula, is going to be 1/2. The length of the base, it goes from -6 to +4, so that's 10, and the height was equal to 4, and so in this case, the area is 20 square units. And again, we are using the normal and tangent lines to get, in this particular case, this particular area. Okay? So there are lots of applications we can use that involve normal and tangent lines.